lateral stability. Okay, so if we talk about the lateral stability, means we are talking about the rolling moment, right? To talk about the lateral stability means we are talking about the rolling moment. Rolling moment. And if you check, rolling moment was denoted by L. Okay, and this rolling moment is always about which axis? About x axis. Okay, and this x axis was called as longitudinal longi, longitudinal axis. So always remember, rolling moment is what always about longitudinal axis. Okay, about longitudinal axis. In simple way, if I draw the diagram here for the plane, okay, so suppose here this is plane, so this axis is nothing but x axis. Okay, this is nothing but x axis, and this about this x axis, whatever the moment will have, it will be rolling moment. This is nothing but rolling moment, okay, L. So rolling moment about x axis. All right, and what is the control surface for the rolling moment? So obviously control surface for the rolling moment is nothing but ailerons. Ailerons, right? Ailerons, the component which is responsible for the rolling moment. Okay, that is nothing but control surface. So this already we have discussed. This is nothing but control surface. Control surface. All right. Anyway, now so if you criteria, if you check, just like for the longitudinal static stability we had seen the criteria. Okay, so similarly here also we will have a criteria, and that criteria we have to follow for the lateral stability also. Okay, so basically if you talk about the lateral stability,
Sir,
lateral
Sergey,
stability, anyway, so first the criteria for lateral stability is positive. Okay, the criteria for lateral stability is positive. Okay, lateral stability is positive, positive roll. Okay, is positive roll or rolling moment should positive roll should result in negative rolling moment. Non negative rolling moment, that is dl by d phi. I will tell you what is phi. If it is negative rolling moment, that means it should be less than 0. Okay, means dl by d phi, negative rolling moment, means less than 0. Okay, means less than 0. In case of the lateral stability, we have a rolling moment. Okay, and that rolling moment we have L. Here it is denoted by L, and phi is the, because once the airplane is what is started rolling, So that airplane will tilt tilt from the vertical, and that angle called as a banking angle. Okay, that angle is called as a banking angle. That angle is called as banking angle. So phi is the banking angle, just like we had in pitching moment. In longitudinal static stability we had pitching moment, and pitching moment was nose up and nose down, so we had taken angle of attack. So we had written dou cmcg or dou m by dou alpha, or dou cmcg by dou alpha we had written. Similarly, for the rolling moment, we have to measure with respect to the phi angle. For the rolling moment, phi angle will be there, and phi angle is nothing but the banking angle. Phi is nothing but banking angle. Okay, so always remember the rolling moment will occur about the longitudinal axis, and that longitudinal axis is nothing but basically x-axis, that you know. So always remember, lateral stability is the neutral or inbuilt ability of the airplane to recover from a disturbance in the lateral plane, that is rolling about the longitudinal axis without any pilot input. Without any pilot input, if the airplane is what, after getting disturbance, if the airplane is what, rolled and it comes to its original position, okay, then without any pilot input, means without using any control surface, if the airplane itself coming back to its original position, then you have to say it is the plane is laterally stable. All the plane is having lateral stability. That's the mean of it. Okay, now what will happen to the a plane? Suppose plane is what simply we have here. So uh, once the plane is what disturbed, then what will happen? So I just want to draw one a simple diagram, the so you will understand like how the rolling is going to happen. Okay, that's the point here. Now see, so when the plane is what laterally stable, when the plane is what laterally unstable, when the plane is what laterally neutral stable, that I want to just show by the diagram. Formula, it's very simple. Formula, mathematical formula also I will give, that you will understand. But with the diagram, you just try to understand how the airplane is what of getting disturbed, and before disturbance and after disturbance, what will be the aircraft attitudes. Huh? That is the what is the aircraft orientation or attitude. So once you understood the diagram, then everything will be very clear. Anyway, now I'm just going to take the condition when the aircraft you are simply flying, or you can say the aircraft which is undisturbed flight. So because we want to see the rolling moment, so better we'll see the front view of the airplane. So front view of the airplane in the sense, uh, now this is the front view of the airplane. This is the front view of the airplane. So this plane is what, simply flying, front view of the airplane, and it is the undisturbed flight, means it is before disturbance. Okay, it is before disturbance. Now what will happen once the air will come and hit to the uh, aircraft? So it will start rolling. So how it will start rolling, you just see. It will follow the pattern. Pattern will be something like this. I will draw the diagram nicely here. Once the rolling is started, so rolling means what, the wing, uh, like right side wing will go up and left side wing will go down, that then only rolling will be started, or you just opposite you can say. Okay, so what will happen, a disturbance in roll will cause one wing to drop and other will rise. That is the rolling, right? And when the aircraft is what blank bang, the lift vector is inclined and produces a side slip into turn. This is the simple idea. Already we had discussed this, how that rolling will be there, and how yawing will be there, and how rolling will be there. That already we had discussed. Okay, Now, so coming to this, uh, if you draw the multiple plane diagrams, so it will be more clear. Now, this aircraft is what is stable. It is without a disturbance. One disturbance came and hit to the plane, then the plane will tilt or it will roll. So rolling will, in the sense, one wing will go down, another wing will go up. Okay. So now this airplane is what, like this after disturbance. Okay. This is before disturbance. This is before disturbance, and this is after disturbance. After disturbance. Okay. So multiple plane diagram I will draw, then it will be more clear. So once disturbance came, then it start rolling, means this wing will go up and this wing will go down like this, and this will be continuous. Okay. So you can say it's like this. Okay. Bank angle also you may get banking angle phi. What is the banking angle? The plane is what making angle from the vertical. Okay, the plane is what making angle from the vertical, so that is bank angle. In turning flight I had explained the slide slip will be there, and obviously one wing will go up, another wing will go down like this. It will be continuous, but the airplane is what, suppose laterally stable, so it will try to come back to its original position. So again it is like, again it will try to restore its original position. So because of the disturbance, what was happening, the plane was, this wing was going down and this was going up. This was the because of the disturbance, no? Because of the gust, because of the turbulence, the plane started rolling, right? Where is the phi angle? If you say, then phi angle is what, nothing but, in turning flight already I had explained, this is what phi angle. Okay. Anyway, but if this airplane is what laterally stable, then this plane is, because this now in what direction moment is what acting, in this direction moment is what acting. uh, Once disturbance came, then moment is acting like this. So this wing is what, this side wing is going down and this side wing going up, that is rolling. So this moment is what, applied moment because of the disturbance. But at the same time, once the airplane, you are saying this airplane is what, laterally stable, so restoring moment will be there to make a stable airplane. So a laterally stable airplane, so restoring moment will come, and that moment will be in just opposite direction like this. So again this wing will try to come back to its original position. So this wing will try to go up, and this wing again try to go down, and finally the airplane will achieve the same original position, just like earlier one. Okay, like earlier one, just like this one and this, it must be same. So if this thing is what happening during the rolling moment, before disturbance and after disturbance, okay, so if you check the last orientation of the plane, it is just like a initial, means the airplane get disturbed, it started rolling, banking angle there, turning is started. Okay, I mean, because of the that side slip, obviously it changed the orientation. But if the airplane is what, laterally stable, so it will try to come back to its original position. Then again it's got its original position. It means this is nothing but laterally stable airplane. So this is what is stable. This is what is stable, laterally stable. Now coming to the second diagram. Okay, coming to the second diagram. Now see, the airplane is what, somewhere here I will go fast little bit, because now you understood the concept how it is going to turn. This is the orientation of the plane. Once disturbance came and hit to the airplane, so it will change the orientation. This plane, this wing will go down and this wing will go up like this. and orientation of the plane will be like this. And this orientation is what? Continuous. I mean, once it is turned, then it is the same with the same angle, banged angle, it is now turned actually. So the same orientation we have after, even though disturbance gone, then the same orientation it is had, it is not going back actually. So this type of stability called neutral. Okay, this is the neutral. Uh, Once disturbance came and hit to the aircraft, it changed the orientation, but even though its disturbance gone, but airplane not able to come back to its original position, or not it is going away from the uh, continuous, going away from the present condition. So it is not continuous from the continuous, not going for the unstable condition. It is somewhere, it is set now, set in the sense, once air or disturbance came and hit to the airplane, the airplane will change the attitude, the airplane will change the orientation, and now whatever the new orientation it is got, it will set there, it will fix there. It is not going away, it is not going back, it's set there. So this type of uh, lateral stable lateral stability called neutral stable condition. This is neutral stable. Okay, the third one we are going to talk here. Third one is nothing but third one. So we have the plane here before disturbance. This is the plane before disturbance. Okay, front view of the airplane. Once disturbance came and hit to the aircraft, then the this right side wing will go down and left side wing will go up. Okay, like this. Okay, and this will be continuous. This will be continuous. Okay, this will be continuous, or I have to show more and more because this is going continuous away from the actual position. So another color I will take. Okay. So it is continuously going away and away from its original condition. So I must draw like this. Will be like this. Okay, so this will be continuous for the aircraft. Continuously it is going away from its original position. It means it is not having a initial tendency to come back to its original. It is continuously going away, 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 away. Okay, so this is nothing but, this one is nothing but unstable. This is nothing but unstable conditions. So that is the mean of it. Okay, anyway, now this is all about the uh, different case we have taken: laterally stable, laterally neutral stable, and then unstable condition. Okay, lateral unstable condition, that is the third one. Third one is the lateral unstable, second one is the laterally neutral condition, and first one is the laterally stable condition. All right, so hope with the diagram it is now clear. Now this thing also we can write in terms of a mathematical formula, which is also very important. Just like in longitudinal stability we had written dou m by dou alpha less than 0. What we have to write here? We have to write dou l by dou phi, which is less than 0. Okay, now so I'll make the uh, three different cases. That three different cases is nothing but case 1, case 2, case 3. Okay, these cases are, these cases are dou L by dou phi, which is less than 0, which means aircraft is laterally stable. Okay. Now dou L by dou phi, which is equal to 0, means aircraft is laterally neutral condition. Okay. Dou L by dou phi, which is greater than 0, that means aircraft is laterally unstable. So in these three cases, you need to remember question they are asking from here. Okay. Number one. Number two, based on this, because del L by dou phi or dl by d phi, this is nothing but this is the slope. Just like a CMCG versus alpha, I told you there is the slope for the longitudinal static stability. Similarly, we have a slope here between between rolling moment and angle of roll, which is also called banking angle. Okay, so I must write here L is nothing but rolling moment. L is nothing but rolling moment, and phi is nothing but angle of roll or banking angle. Okay, banking angle I explained nicely in turning flight. So the same banking angle we are talking here. Okay. Anyway, because once rolling is started, then banking angle will come. Okay, from the vertical. Here I have shown a small diagram. So hope you able to connect this banking angle, right? Banking angle. This is the plane, simple, okay, mg, and this is lift. Once the airplane is what going to roll, so obviously this part is what going down. So this side the plane will go up, and this part will be like this. So from the vertical axis, okay, this lift axis is what making angle. Okay, this angle is nothing but phi, called banking angle. Or from here also you can say, because horizontal is nothing but this is the horizontal, so this angle, which is nothing but phi. It's your choice. You are going to write in vertical or from horizontal, but the both angle will be same, right? Anyway, so if you want to draw the slope, so what will be the slope? You have to draw the L versus phi plot, and then this will be nothing but uh, this is what phi, and this is what L. Okay, phi and L. Now you can take, anyway. Okay, so we can have three conditions, which is nothing but neutral. This is the positive slope, and this is the negative slope. Here, this is what dl by d phi. There is no slope, so dl by d phi is 0. Here, dl by d phi greater than 0, dl by d phi less than. Always remember, okay? This is very important. This is what is stable, unstable, neutral. Okay? Always remember. Anyway, this is the one thing. But at the same time, we have a side slip angle also. Side slip angle. Okay. Side slip angle. So basically, that side slip angle, if you talk, that side slip angle is what denoted by beta. Side slip angle is what denoted by beta always. Okay. So in terms of beta also, you can write the same relation, just like a rolling moment you have written here. So we can write in terms of the side slip angle. Okay. Side slip angle. So now you can say this is what phi. So this is the phi. I will give the different name. This is now beta. Simple only. This is now beta, where beta is nothing but side slip angle. Side slip angle. Okay. Now, so if you talk about the side slip angle here, so in terms of side slip angle, how to write the relation? So for the rolling stability, the requirement for the roll stability, it is also the same. Okay, you can write in the same way. That time your criteria, just like a dl by d phi, you have written dl by d phi less than 0, dl by d phi greater than 0, dl by d phi is equal to 0. Similarly, you can write for the uh, in terms of the that side slip angle also. So we can write the restoring moment is also is also a function of side slip angle beta. Side slip angle beta. So 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 second point, the requirement for roll stability roll stability is that you can write the same dou L by dou beta instead of phi, because if you are writing in terms of the side slip angle, both option you have. You can write this stability criteria in terms of side slip angle or in terms of banking angle. Both are the same thing. Okay, one is you are measuring from the vertical axis, then it will be called a banking angle. One you are measuring from the horizontal axis, then it will be called side slip angle. All right. So this dl by d beta, because L is the rolling moment. If you want to write, if you remember, for the pitching moment, actually dou dm by d alpha was there. M was the pitching moment, alpha was the angle of attack. But in terms of the coefficient, I had written cm divided dcm by d alpha. Try to connect. So similarly here also you can write in terms of the coefficient, that is d that is d cl divided by d beta, which is less than 0. Now this cl is not lift coefficient. This is the rolling coefficient. Okay. Here this cl is nothing but rolling moment coefficient. So don't get confused. Okay, just try to connect, because L is not lift, L is the rolling moment. So this CL will be denoted here rolling moment coefficient. So also you can write dCl by d beta less than 0. That will also be correct. There should not be any confusion. Like here also you can write what you can write. You can write dCl by d phi greater than 0. If I am writing CL, so don't think this is the lip coefficient. Okay, why? Because this L is what? This L is not lip coefficient. This is what? Rolling moment. So what is the CL? CL is nothing but rolling moment coefficient. Okay, and this CL is rolling moment coefficient only here. In aerodynamics, it is lift coefficient, even though in performance it is lift coefficient. But here, as we have decided L is the rolling moment, so this CL becomes rolling moment coefficient. So don't think this is the lift coefficient. Again and again, I'm saying, okay, because most of time the this confusion may happen. So better you just give stress here and just try to remember this. Okay, this is less than. Sorry, this is the less than, and similarly here also. So basically, both you need to remember. Okay, in terms of the side slip angle. So in terms of side slip angle, I have written here. So requirement for rolling stability, the CL, uh, uh, dCL by d beta less than 0, where beta is nothing but side slip angle. I think this one is enough information I have given. Now this part is done. Now we'll go for the, at the same time we'll go for the directional stability. Okay, we'll go through directional stability. So